Okay, everyone, welcome to the LAMP training today. This meeting today is the outcome of a forum post on the LAMP several weeks ago now, and there's actually it's actually a very big topic, and so this is an overview. But understanding the LAMP is important to understanding self-hosting, which is what a lot of us do. It's not possible to go into a lot of detail today. And while we're recording, please keep your questions to the topic of the lamb stack. With that, I'll turn it over to the chief cook and bottle washer of Bus Touch, David Book. Oh, I have to give you the screen here though too.
Yeah, so thanks, Sue. Just like Sue said, we're going to we're going to have a conversation about what we're calling a lamp stack, which is absolutely slang. And so we'll establish what that means, what is it a slang word for, what is its purpose, and all that kind of stuff. The one thing I am going to say, just kind of right away, is that this is going to be either a very complicated conversation for somebody who has no idea what we're talking about. It's going to all feel very cryptic. Or it's going to be absolutely simple and not even interesting because you have a background in maybe web programming or website administration or something like that. So depending on your perspective and your background and your experience, you may get a lot out of this in terms of new information, or you may come away a little bit intimidated. The assumption is that because you're in this hangout and because we're having this meeting titled Lamp Stack, that you're at least interested. And so I won't be too worried about those who are kind of intimidated. We can always come back and revisit this. So we're going to talk technically for about an hour. We're going to go through a couple of demonstrations to try to explain kind of what I'm talking about and what I mean. And we're going to first start out by saying, what is a lamp stack? So I've got a little document here that I prepared to try to help us all understand what we even mean when we talk about lamp stack. So LAMP is an acronym. So I put down here L.A.M.P. And LAMP refers to, each letter in the acronym refers to a different piece of software that's running on your typical web server today. So if you have a GoDaddy account, or you have a Bluehost account, or you have a virtual private server, say at Rackspace or something like that, it's probably running a LAMP stack. And what that means is it's going to be running 4 different pieces of software. We're going to talk about these for a few minutes to establish what a LAMP stack is. So the first letter in LAMP stack is L, and that stands for Linux. So I'm going to read what I typed about 30 minutes ago, and then we'll talk about it a little bit. So Linux is the operating system. Think Microsoft Windows, Mac OS X, iOS on your device. It's an operating system. So the operating system is software on top of the raw hardware on a computer, network cards, hard drives, etc. And it manages multiple processes, tasks, memory, it manages file system access and other low-level control over the actual hardware itself. The operating system does not provide any web server functionality whatsoever. It's an operating system and only an operating system. So let's unpack that a little bit. Basically what I'm saying is that without an operating system, we all know our computers wouldn't be much good. But with an operating system, they're tremendously powerful. We can do things like save data to a disk. We can do things like run a bunch of processes. Think of your Mac OS X machine. You might have 10 or 12 different applications running at the same time. It's the operating system that's managing those processes or applications. But I also said here that it's not a web server. If all you had was Linux running on a piece of hardware, on a Dell-built processor and a who knows what kind of hard drive, you couldn't serve up web pages. You couldn't serve up web pages. And by the way, serving up web pages is very much slang for the more technical definition of what that means, which is you couldn't answer HTTP requests. You couldn't answer web requests from browsers if all you had was Linux. So that takes us to the next piece of software in our LAMP stack, the A, and A is for Apache. So I'm going to read this. Apache is web server software. It runs multiple processes under the Linux operating system. Its primary purpose is to answer requests from web browsers and to return documents. In most cases, HTTP requests, what we call web requests, just in the casual world, are either deemed GET requests or POST requests. We'll be getting into that in a little bit, but just put in your head that every request is either a GET or a POST, and the distinction is very important. After finding the document, it returns its contents to the requesting browser. So let's think about this for just a second here. Since it runs under the Linux operating system, this also means that we can't run Apache unless we have an operating system. There are versions of the Apache web server software that will run in Windows and Mac OS X and all of that kind of stuff. But for the basis of this conversation, since we're calling it a LAMP stack, Apache runs under Linux. So far we have a computer, which we call a web server, that's up there in the cloud at GoDaddy or Rackspace or anywhere else for that matter, a web hosting account. It has an operating system, Linux, and it has Apache, two different pieces of software that are, in this case, working together. The next piece of software in our LAMP stack, the M, stands for MySQL. MySQL is a database software. So I'll read this here. MySQL is database software. It runs under a process under the Linux operating system. In most cases, it's running in a single process. Multiple processes can be configured, and we'll talk about that in just a sec. Its primary purpose is to organize data into tables, which contain rows and columns. And the important thing to remember in terms of your LAMP stack is Apache cannot communicate with MySQL software directly. Apache doesn't know that a database exists on this computer that we've set up, our web server. It doesn't know, it doesn't care. There could be 10 different types of database softwares installed on this hardware, and Apache wouldn't care. MySQL, Microsoft SQL Server, Sybase, Oracle, all of these types of database software are not available to Apache, so to speak. So it does run under Linux, just like Apache runs under Linux. The one thing that I want to touch on here, which is a little bit high-level thinking, but it's important. If you remember up here in the Apache section, I said it runs a process, or it runs processes, multiple. Back to the example of your Mac OS X computer running iTunes and iPhoto and Xcode and Safari and all these multiple processes, Apache very much does that. Each time a browser out there makes a request for a document that's on the web server, it'll launch a new process. Certainly there's a cap to this number of processes, but it'll launch a new process to answer that request. And it does that so that it can answer lots and lots of requests at the same time. That's one of the secrets to how a web server can handle millions of visits with lots and lots of processes. MySQL is a little bit different. It generally runs a single process. You won't find very many servers out there with 10 versions of MySQL running. The database software is generally running in one process and just sitting there waiting for somebody to ask it for data. So that is again, high level, but it can be important down the road if you're trying to manage or administer an extraordinarily busy machine or machines and you're trying to figure out what's slowing things down. So just know that Apache runs a bunch of processes on purpose. MySQL generally runs one. Then the last part of our LAMP acronym, the P, stands for PHP. And this is really the nuts and bolts of where our conversation is going to go today. And so PHP is middleware. And I put that into quotations because, again, that's slang. PHP is middleware software. PHP allows developers to create dynamic, which is ever-changing, content or documents and deliver them to web browsers. Apache communicates with PHP. PHP communicates with MySQL. In most cases, Apache will route any incoming HTTP request, whether it's GET or POST, to the PHP software if the file extension of the document being requested ends in PHP. So I just said a lot there. And some of the examples that I give you here in just a minute will really help us out. But the critical thing here to understand is PHP doesn't answer web requests. Apache does that. But PHP does talk to the database. So if we want to do something dynamic based on data, or based on maybe some other dynamic information like the date or the time of the day or something like that, we can't write a static HTML document and deliver it to the browser because it's going to be just that, static. You type the date in and it would never change, and everybody who asked for the document would get the same date or time. You'd have to change it every day. And we'll get to an example. So you'll see here, to kind of recap this, that basically Linux we don't care much about as a PHP developer, because it's just the operating system and just kind of happening, and it's required to run these other 3 packages. So Apache, MySQL, and PHP very much work together to answer dynamic web requests, or requests that tend to change often. I'll give you an example. When you go to buzztouch.com and you visit the forums, that page changes constantly, right? It's a web page that you're requesting, buzztouch.com/forum, but it's always different, right? As many people, there's a lot of people out there who think I'm just, manually typing this stuff in there, but believe me, that's not what's happening. It's dynamically happening based on all of our inputs. So we create a forum post, it goes into the database permanently to be stored, and then when you visit the forum, Apache answers your request, and it asks PHP for the document that you're requesting, which is the forum's homepage. So PHP says, no problem, let me go get you that document, or more specifically, let me create that document because it's dynamic. I need to make it for you right now so that it's accurate and the most up-to-date as possible. It gives it back to Apache, it being the document, which returns it to the browser. So that relationship right there is the essence of what we do as web programmers when we're working in the LAMP environment. So WordPress, BuzzTouch self-hosted software, PHP, MyAdmin, there's all kinds of web applications that are PHP web apps that we rely on every day. Amazon, all these different, Facebook is a web app. And so that's what we're talking about. There are lots of different angles and lots of different directions we can go in terms of details about each one of these. And like Sue alluded to at the beginning of this meeting, I'd love to have a 3-hour conversation about Apache or MySQL or PHP or Linux, but it really is beyond the kind of scope of this conversation. We're just trying to get our heads around what is this stuff. And so let's take some concrete examples now, and we'll see what happens. So if I take this web address and load it in my browser, and I request this, we're going to try to walk through this step by step, what happened. Because my browser got this document back, right? I made an HTTP request by hitting enter or return or go or whatever in my browser for a document that we know is living on a LAMP stack setup server out there. So Apache answered this request. Apache is what we call listening for web requests. So my browser made an HTTP request for a document called lamp.html in a folder called system. Now, I actually made another folder called lamp because I got a little testing environment set up. So we'll work in the lamp folder today. The concept is exactly the same, but I wanted to change that file location because I want to show you guys that there is a path to this file, just like in your Finder or just like in your Windows Explorer when you're browsing for files. The files are living on this machine somewhere, and Apache is doing nothing more. In this case, it's doing nothing more than finding this file and returning it back to the web browser. And that's because the web browser, Chrome in my case, made a request. Hey Apache, hey web server at buzztouch.com, can I have this document? Sure. And it returns it, and it does that lightning fast. And I can refresh this over and over and over again, and depending on a few different factors, the speed in which it returns the document, of course, might change a little bit. If I'm asking for a document that, let's say, is on a machine in China, it might be a little bit slower to come back to me. Or if I'm asking for a document that's on a machine that's maybe underpowered or overwhelmed, maybe I have to wait a little bit. So the time that it takes to answer my request, the browser's request, does tend to fluctuate a little bit, and we're all used to slow websites, right? Slow websites are no fun. But let's go back to these notes here and revisit this idea of multiple processes. How many instances of, say, iTunes do you think you could run on your computer without crashing it? 10, 20, 50? Can you run, 1,000 applications on your Mac, MacBook Pro or your Windows machine without crashing? Probably not. Probably not, because the applications that you generally run as a normal person are pretty heavy, memory-intensive applications that consume a lot of resources. So your machine's going to run out of power. Well, it just so happens that an Apache web server software package, it's not very memory-intensive. It doesn't do much. So you can launch many processes to answer individual requests pretty easily. Now, technically, we're not launching Apache over and over and over again. We're launching just once when we start the computer. But it does spawn little processes to answer these requests so that Sue and Tom and Jake and Miguel can all ask for the same web page at the same time. We don't have to wait for each other. So I think that's an important concept when you're working on a web app. When things get slow, you got to try to figure out why. And rarely is it Apache's fault. Very rarely will Apache be a bottleneck. It can be, but generally speaking, it's pretty darn amazing how fast it can answer these requests. But I digress a little bit. This is a simple request for a document that already exists. So let's do another example of another simple document that already exists. It's the same address, but it's a file called lamp.txt, which apparently doesn't exist. So I'm only going to do this for just a sec. I know this one exists. There we go. So this is a text document. Apache completely capable of finding the document, lamp.txt, handled it with no problem, found it, returned it to the browser. Now, it doesn't look like HTML, like our previous example, because we know that an HTML document has, a certain kind of style, right? You'll notice the font is a little different. That's because our browser is expecting an HTML document, and it's applying some kind of default styles to it. Because this is a pretty simple, if I look at the source of this document, it's a pretty simple HTML document. It doesn't have anything fancy in it. But a text document, like this one, it doesn't have any markup, or it's not an HTML document, it's a text document. So our browser is just like, here you go, it's just text. So the only reason I'm demonstrating this, or the reason I'm demonstrating this right now, is because I wanted you guys to see that PHP had nothing to do with these two requests. Apache didn't need the PHP software to answer these requests. It knew right where the document was, and it found it, and it returned it to the browser. So PHP didn't even need to be running on this machine to answer these two very simple web requests. One for an HTML page, one for a text page, or a text file in essence. So the same thing could be true for an image, a style sheet, a video, right? Lots of different types of files on our machine can be returned by Apache with no other intervention, no other nothing. But if you ask for a something.jpg, it's a picture, or a PNG or whatever, as long as you give it the right file name and it exists on the machine, it'll be returned by Apache. And that's very important because remember, Apache's super fast. Super fast. But you might be asking yourself, well, wait a minute. We're talking about dynamic web pages. We're talking about control panels. We're talking about, buzztips.com or my self-hosted software running on my site. That's a completely different question, and that's where PHP comes in. But I wanted to demonstrate to you that indeed is kind of how it works. So I have these three documents right here running in my little text editor. So what I'm going to do is I'm going to open up all three of these in three adjacent windows, or three adjacent tabs. So we have our text document, we have our, find it here, lamp, we have our HTML document, and we have our PHP document. Okay, so these three tabs, that one, and that one, are open in my browser, and the source code, or the actual, you know, editing and the learning that we're going to do is in my text editor. So let's take 5 minutes right now and see if there's any questions so far. I don't think there are, but I'm looking down here. Oh, so Chris looks like he's got a question. Let me read it real quick.
Okay.
You mentioned Apache. Okay, so Chris is saying, and I can't figure out whose background noise this is. When we get questions here, let's see if we can address this one. I have a question about something. Let's see what he wrote here. Apache can handle many simultaneous requests, but MySQL cannot. How many simultaneous requests to a PHP page connecting with a database would start to cause issues? That's a fantastic question. And the answer is, depends. I'll give you some rough numbers. A general kind of baseline web server running on a low-cost hosting account, let's say at HostGator or something, will probably start to slow down if a couple of hundred requests are made literally at the same time, only a couple of hundred. But a couple of hundred web visitors on your website literally asking for the same page all at the same time is actually not too bad. Because generally they're asking for lots of different things, and they're not all asking for the same thing at the same time. So a couple of hundred is pretty easy for almost any machine to handle. However, in the case of like a backend like I run, or a backend like you might run at Facebook, you might think to yourself, wait a minute, a couple of hundred is a joke. There might be a couple of million requests for the same resource. And so then it becomes an issue of really nothing more than hardware. How fast is your computer? And do you have giant amounts of memory? How many machines you might have? Sometimes you spread this over multiple machines. And PHP's ability to answer all these requests, and MySQL's ability to answer all these requests and feed that back to Apache. And so, Chris, to concretely, accurately answer your question, there's no way to know how many because it depends on your environment. But I can say that several hundred requests by, browsers or phones. Remember, phones make internet requests also. Is not a big deal. If you get up to 1,000 simultaneous connections, you're probably going to start having some issues. Generally, up to even 1,000 requests at a time isn't going to crash your machine. It'll just kind of slow things down a little bit. Hopefully, that's some kind of number. I can tell you that BuzzTouch.com, it probably answers. Well, I know that it answers several million requests, a day. Not from several million people, but from hundreds of thousands of phones and devices, millions actually, that contact BuzzTouch.com's backend for information. And it certainly wouldn't be able to do that on one machine, unless we had a supercomputer, right? If I had a machine with endless amounts of memory and endless amounts of hard drive space and all of that, yeah, presumably you could load all those requests pretty fast. It just so happens that those machines are pretty expensive, and generally you end up running more than one machine. But hopefully that helps that one. I don't see any other questions, so I'm going to kind of move on. So, and I'm moving you guys into view here because I'd much rather look at you than just talk to myself. So I've got you over here on the right-hand side of my screen. Okay, so let's look at our text document. Why might we have a text document on a web page on a web server that people are going to request? There's some reasons you might have a simple text document. Maybe you have, and I've got some notes over here, maybe you have a text document on your page, on your web server, that holds some JSON data, right? Maybe you want to feed JSON to a phone or to some other external place. So if we go to our browser here and we look at our text document and we refresh this, we get that JSON data. So I made an HTTP request, a web request. Apache found the document and returned it to my browser. And this is the contents of the document. So that's a simple example how you might want to provide in a text document at a web address some structured data for something. That's just an example. A lot of questions like security and who can look at this and all those are completely off the table for this moment right now. Maybe our JSON text document provides child items to power like a menu or a map or something. Right? It's a simple text document. It's created in advance and saved on the web server. It's not necessarily very easy to change because it's just made, but I might not need to change it, right? Maybe I have a list of restaurants, you know, in my town, and I make map locations, you know, child items out of them, and I don't have to change that very often. And I'm not worried about protecting it. I mean, anybody on the internet can find this file right now. And so, no big deal. I'll just throw a text file together. Won't worry about PHP, won't worry about MySQL. We'll let Apache handle these requests. No problem. So these are just some examples of what you might want to do with a text document. HTML, on the other hand, let's look at an HTML document. I just made a simple HTML document here. And let's look at this and refresh this. And let's talk about this for a sec. What do you use HTML for? Hypertext markup language. Generally, you use HTML to structure something that you're going to display. Right? You're going to show it to a user that's using a web browser because web browsers are extraordinarily good at turning HTML markup into something maybe pretty or organized or somehow fancy. Right? So when we're writing an HTML document, we can do things like add, you know, lines, we can add bold text, we can do all kinds of things in HTML that doesn't have anything to do with the browser. I mean, doesn't have anything to do with Apache. It's the browser that's deciding that that line should be bold. It's the browser that's deciding that there should be a horizontal rule right here. Apache just found the document and sent it back. That's all it's doing. No MySQL, no lamps, no PHP, nothing. Just an HTML document. So in kind of web programming 101, we generally start with learning how to make HTML documents, which is completely fine and reasonable, and there's nothing wrong with that. Once again, you might want to do something in your iPhone application or your Android application. You know, this is my list of restaurants. And you could list, you know, a line. You could put Joe's Pizza. You could put, you know, Bob's Diner, whatever. And you could return this to your iPhone application. Something like that. But because it's not JSON, you wouldn't be able to expect your code to kind of parse it and read it or whatever, because it's markup that it's designed for display. So you would probably show this in like a web browser or something in the phone. I wouldn't recommend that necessarily, but you could do it. And I'm just showing you what the purposes of different documents are for. So HTML document, text document, nothing to do with PHP, nothing to do with the database. So let's start talking about the database and the fun stuff in PHP and what we can do with that, because that's really what I think most people came to this meeting for. So here is my generic PHP document. And let's talk about this document right here and how it's different and not so different than those other documents. Right now, I could also write, this is, you know, I can also create HTML in this PHP document. The only thing that makes it a PHP document is the extension .php. It's the same, in essence, the same content as our HTML document. But this is my list of restaurants created dynamically, right? We'll just give that title to it because that's kind of what we'll want to work towards. But if I refreshed it now, it's the same old list because I've just pasted HTML right here. That will never change, ever. If I never change this document and, you know, if that 10,000 people requested it, this is what they would get. However, and this is the secret, or the important part. It has a PHP extension, the file name. So because it has a PHP extension, Apache doesn't simply find the document and return it to the browser. It first says, hey, wait a minute, this has a PHP extension, this file that David's requesting with his browser. I'm going to go send this off to PHP, and I'm going to say, hey, PHP, you deal with this. And when you're done dealing with it, bring it back, and then I'll return it to the browser. That's why we call it middleware. I've described it in different conversations as a butler, right? Apache's your butler. PHP's kind of the hey boy standing in the dark doing nothing, just standing next to the butler. Somebody knocks on the front door of the house. The butler says, hi there, what can I do for you? And they say, oh, I'm here to deliver the mail. And the butler says, no problem, here, I have some other mail for you. And the guy leaves, the visitor leaves. The butler didn't do anything. That's Apache. He just turned around, got the mail, handed it to the mailman, got the new mail, done. But if the knock on the door said, hey, Mr. Butler, I need this so-and-so document with a PHP extension, he'd have to turn to this guy waiting in the dark, the PHP man, and he'd have to say, hey, PHP, run off to the library, go find this thing and bring it back. And then I can give it to the guy at the door. So PHP runs off and comes back and does something magical with this request, gives it to the butler, and the butler's happy. So the butler, Apache, just routes things to PHP if he doesn't know the answer to these questions, like what is this thing? So if it ends in PHP, off you go to the library, little PHP man. And of course, leading back to Chris's question, what if the butler needed 50 things that ended with PHP? The little kid would run off to the library, the PHP kid, he'd run off to the library, he'd come back, and he'd get another one, and he'd run back, and he'd get another one, and he'd run back. It's not as skilled as doing a bunch of things at the same time as Apache is. So that's an important concept, because as things slow down, generally bottlenecks are related to PHP and databases. Generally bottlenecks are related to PHP and databases, because the little guy who ran off to the library to answer this question, he may not know the answer himself. He in turn might have to say, hey, database guy, go get me this list of restaurants so I can make a web page out of it so I can give it to the butler who can give it to the guy at the front door. So the butler can't talk to the database, but the PHP guy can. And you can see how that tends to slow things down. So you got all these people running around the house while the butler waits, while the guy at the front door waits, and finally all the stuff comes back and he can answer the question. So I know that sounds a little elementary, but for people who don't have any idea what I'm talking about, it's sometimes kind of fun and silly to say, wait a minute, who's at my front door and what the hell do they want? Because as we try to diagnose things and as we try to figure out what's going on, you know, putting it in real world terms really, really helps. Okay, so let's move on with our PHP conversation. So here's a PHP file that doesn't have any PHP magic happening. None at all. So let's get rid of all this. And let's get rid of this. And let's just make it blank. And the reason that we're going to make it blank is because we want to write whatever the output is dynamically based on something magic, like the date or the user or whatever. So let's start there. So there are lots of different ways to introduce PHP code into an HTML document. I like to do it simply. I generally put my PHP code to the furthest extent possible at the top of the page. We call it the top of the page. So PHP, a lot of the meat and potatoes of the logic and what's going on in a PHP script, which is slang for what we're making, will be at the top, and then the HTML output will be at the bottom. But wait a minute. What if we don't want to make HTML output? What if we want to make JSON output? Because we want PHP to create a dynamic list of restaurants to power our menu or something like that. So let's start there and say the heck with this HTML for now. Let's just get rid of all the HTML. Can we do that in a PHP document? Absolutely. We can do whatever we want. It's our document. The only thing that's required to use PHP is we have to tell what we call the interpreter, PHP that I'm going to write some PHP code in here, in between these tags. Now I can intermix PHP code in my HTML like this as many times as I want, right? Like I can use the word echo, by the way, to print something to the screen. Hi, David. That's in PHP. And then I could do some generic HTML, like a bold tag. Hi, Sue. Or a line break, or a horizontal rule. And then I can introduce more PHP. Right? So I can start PHP logic or a tag here and end it, and then do some more HTML, and then go back to PHP. I've just kind of introduced this in the HTML document in a lot of different random places to demonstrate to you that we can indeed do that. But depending on what you're trying to create, you may not have any HTML at all, because you're not delivering HTML, you're delivering something else. So I'm going to go back to that. I wanted to just make sure we all knew that you can do this PHP stuff anywhere you want. That's completely okay. So let's start a PHP document, and let's use the echo word like we just used to echo one array of child items. Now there are some tricks when you use echo. For example, because you include things in quotation marks, we want to show quotation marks on the screen, so we need to, what we use the word escape these quotation marks. So we need to escape these quotation marks with a backslash, or PHP won't know what's going on. So we escape quotation marks with a backslash, and then we end every line of PHP with the semicolon. So let's echo that line, and then let's comment this out. And PHP comments are just like Java comments, backslash, star, right? So all this is going to do is print that to the screen. There you go. There are no child items in this array, but we began the output like we wanted. And maybe we want to end the child items. Of course, we need to echo this. And you'll notice that there aren't going to be any, magic carriage returns or anything. All of the what we call white space is ignored. Doesn't matter. Okay, and that's not 100% true, but generally speaking, it's not a problem. So we now have an array of child items that we created with PHP that aren't very dynamic, but they're here, and it's empty. And maybe we wanted to create one item in here. So these have quotes, so we have to escape the quotes. And there's many, many strategies in terms of doing this. I'm just going to do it this way on purpose, because PHP is extraordinarily powerful. And we want to get good at using it because we can do so many things with it. And we know already that each of these requests is being routed through the PHP interpreter by, and get rid of the comma there, by the Apache web server. So now we're going to have one item in our array. Uh-oh.
You forgot a quote between the 111.
Where is it?
In front of the 111. I think it's the item ID.
Right there. Good call, Jake. Like a hawk. I love it. Okay, so here's our array of child items that just has one thing. Now we could get a little cheesy and print, 10 of them. And as long as we put a comma after each one, it'll still be valid JSON. We don't want a comma after the last one. But that kind of defeats the whole purpose of using PHP. It wouldn't make any sense. So let's get a little dynamic. Instead of just copying and pasting, what do we got there? 7 of them. Let's use some logic. PHP allows us to use logic, programming logic. We can use variables and loops and arrays and all kinds of interesting things. So let's do a quick little for loop. I'm just going to declare variable x equals 0. We'll say we'll do this while x is less than 10. We'll increment x one time each through the loop here, one time each. So we're basically going to do this 10 times. And this is just a simple example to show you how we can create something dynamically. So there's 10 of these, but they're all the same. So that's kind of dumb. Maybe the ID is something like this. Now we have taken the value of x in our loop and introduced it in each item. So it's going to be 0, 1, 2, 3, 4. So we have item 0, item 1, right? So logic. It's very, very normal kind of programming type logic. So that's an example of how we can output JSON using PHP. It is dynamic because we have a loop, but frankly, I mean, it's all going to get. If all of us requested this at the same time, we get the same thing. It doesn't really change. It doesn't really do anything, you know, special. So that's where these other concept of databases and things like that come in. So we're gonna come back to this in just a sec, but we're gonna change gears a little bit. I'm gonna move this down, and we're gonna talk about a very, very important concept that PHP allows us to do. And that's the idea, we've got some notes here. That's the idea that we can include logic or code from other PHP files in this PHP file. So you'll see at the top of everything that I write, everything, we've included a configuration file. And the reason that we include it, and by the way, require once is close to the same thing as using the word include, but I won't get into the differences right now. It's in essence the same thing. And include is a, you know, I'm gonna use word include for today. It's just easier. So include means, hey PHP, before you do any of this, go do that. And if I had another include below that, and another include below that, and another include below that, it processes in order from top to bottom. So if I included this file here, and I included another file here, my other file, it would do this, then this, then this. Important concept. So include files are really important because we want to do things sometimes across a lot of different files or pages, or what we call globally. If you've all seen the self-hosted installation package, you'll see that, you know, the config.php file is like the root, the heart of your app, your web app. You know, you tell it where your database is, you tell it all kinds of different settings and properties. You don't really mess with them after you get them set, but it's included in every page so we can refer to them. I'll give you a perfect example. We can use variables in PHP. So I have a simple PHP file here that I've called lamp-config.php. I've said, hey, PHP, use error reporting. Show me all the errors. I've said, hey, PHP, my time zone is the West Coast. And I've also said, hey, PHP, include this other file. So all of this is happening right there. So now I have this long list of, I think most of you have probably seen my utilities functions file. It's thousands of lines of code of interesting, cool little utilities that we can use without writing them. And a lot of them are cryptic and not necessarily, they weren't ever written really knowing that I would share them with everybody because, you know, I've been writing them for years, but they're super useful once you understand what they're for. And so I always include my utility functions in everything. And so I just do all that in a config file, include it at the top, and I've got all that stuff available to me. So we'll do some extending of that idea. So let's say that in this config file, I made a variable called date now, and I said it equals the date. This is just PHP for right now. So PHP, it's gonna yell at me, and I'll show you why. It's gonna yell at me. Actually, you know what I'm gonna do? I'm gonna do this right here. I want to do it after the error's been turned on. I want to show you why this is going to yell at me. It's interesting. because this kind of freaks people out sometimes. Like, what's going on? They get all like weirded out. If I echo date now right here, and I refresh this page, watch what happens. We get an error.
Oh.
And then we get our child items. The reason we get the error is because I told PHP in our config file, which I've included, which is where I tried to print date, I've told it, hey, show me all the errors. I want to know that. I want to know as a developer that my script has errors. It's easy to suppress those errors and hide them. Right? It's very, very easy. In fact, on most installations, the default is to hide errors. On this installation, I don't think that's the case. That might be. Just trying to show you here that there are tricks. Yeah, there we go. Notice it didn't write the date, but it didn't show the error. There are tricks to suppress errors. That's what the @ sign will do. It's all kinds of stuff. We're not getting into an error trapping PHP tutorial, but I want you guys to know that errors are good. You want to see them because it exposes problems with the code and with the logic that you can only then fix. You don't want to suppress errors ever, with one caveat. One caveat. If you have a live machine that has lots of traffic that you don't know who these people are, in other words, a website, anybody in the world can access the website, you don't want to show those people errors. Yeah. Because they can expose certain things that will allow them to kind of hack into your back end, and you just don't want to show errors to unsuspecting eyes. So when I say always show errors, what I mean is to yourself. When you're working on your application, you want to have errors on. But when your application is live, you're self-hosted, you're whatever, you want to have errors off. That's all I'm saying. But don't forget that they're off when...
There's a switch for that too in the config file in our self-hosting, right?
Absolutely. Absolutely. Makes it super easy. Okay, so I just wanted to show you that this is saying, let me go back to where we were. It's saying, this is just PHP talking to me. Warning, date expects at least one parameter. Right? It doesn't have a parameter. So it's telling me that I need to have an argument, and in the date argument, I know this. It wants a formatting string for the date. So we'll go month, day, year. And now I'm going to get a different error. Haha, because I'm like the error master. I'm doing this on purpose. It's saying, remember, it just told me before that I needed to add an argument to my function. I called a function with empty parentheses, no arguments, or a method. Now it's telling me, hey, it's not safe to rely on the system's time zone settings. You are required to use the date.timezone settings or the date default time zone function. So if I use the date default time zone function and I tell PHP what time zone it's in, and then call date, this function, I won't have an error. And I knew this, but I wanted to demonstrate. This is just a very, very simple example to show you that we're printing the date in one file. See here in the top left of my browser? We're printing the date here, and then we're including this here, so that's what's printing the date, and then we're printing this. It can get very confusing, like where is that coming from? And so include files, and this is a loose rule of thumb, doesn't have to be this way, and I certainly break this exception all the time, but unless you know what you're really trying to do, include files shouldn't output anything. It shouldn't print anything, because when you find something on the screen and you're like, where's that coming from? And you're working on your document and you got lots and lots of includes maybe, it's really hard to figure out where that is happening. So generally speaking, includes don't print things, but obviously there are lots of exceptions for that. Okay, so let's go back to our configuration file and get rid of this print. So we're not printing the date. We're back to where we were. And let's just close our config file because we're done talking about it. And let's instead put that date right here. I don't want to echo it to the screen. I just want to know what it is. In other words, you don't have to print any things. They're just variables. They're just information in our logic. So what if date now, so I'm not going to print this. I'm going to comment this out for a minute. What if date now isn't really going to be helpful for us? Because maybe our logic is, hey, if it's the 7th month of the year, I want to output these JSON items. Or if it's the 3rd day of the week, I want to output these JSON items, right? Dynamic data based on some variable. And so let's just for fun say, if it's July, do all this, and if it's not July, do all that, do something else. So just for fun. So in order to do that, we have to use PHP. Remember, we need logic here, and PHP is where our logic is. Apache can't tell us that. Linux can't tell us that. The MySQL can't tell us that. I mean, yes, I know you experienced people are saying, yeah, it can. I mean, it can, but it's completely out of the context of what you normally do in a programming world. You use PHP to ask questions and get answers. That's what I'm saying. Like, hey, how many users are in this database? Or, hey, what's the date? Or, hey, what's the time of year or whatever? Or go read this file or something. So let's say date now is actually just equal to a month, the 7. And let's say if, and actually date now is probably a bad word. Let's use month. So now we can use that variable if month equals 7, else do something in July. Do something in all other months. Right? So if it's July, let's output these menu items for our menu, our secret menu that we're powering. And we'll say title text is July. And let's output this very same list of items in some other month. So we're going to do this, or we're going to do this. It's just simple logic. So we're creating dynamic content based on some relatively simple ideas. We're still going to create 10 of them in each case, right? This is July items because it is July. What if we were, talking about the 9th month? It's not July now. We're saying do the 9th month. Well, then we're going to create some other month. Very, very simple. So this page or this script is done. And every time somebody requests this address in a web browser, with a phone, whatever, anything that's capable of making a web request, it's dynamically creating the results, returning them to Apache. Apache's sending them to the person knocking at the door, right? The browser. Super, super. I understand this seems either simple or not so simple. It just depends on your perspective. And so let's expand these ideas a little bit. We'll just do these cheesy output items like this, and take another few attempts at trying to understand what's going on. So right now we're creating 10 child items that are just random child items because we're doing it in a loop. I mean, I could create 500 of them. Show you an idea how fast PHP is. There's 500 of them. Amazing, right? We can do, what if we do 5,000 of them? How fast can PHP work? There's 5,000 of them. See, the request is already done. If I'm not loading, you see how small my scroll bar is. Right? PHP is pretty fast. Wait a minute. We didn't go to the database. Maybe things start to slow down if we go to the database, because now we got to ask that other question from that other layer of software and wait for its answer before we can now loop through the results or do something magic. So, before we go to the database, I'm going to create one other example because I've forgotten. We haven't talked about the difference between get and post, and both of those are very, very important, and it's right up on our hour now. So let's pause on the database for a sec and talk about this get or post. What the heck is this? I'm going to put this back down to, say, 5, just so it's faster. What is a get? What is a post? This is not that complicated, but it is important. PHP needs to know what type of request you're making, get or post. If you're asking for a web address by typing it into your address bar, or clicking a link, or just otherwise just visiting a web page, technically speaking, that is a GET request. On the contrary, let's say that, let me get rid of this JSON real quick. I'm going to go down here in my, after the PHP, I'm going to make some valid HTML just to demonstrate this. In our HTML document, I'll prove to you that we're here. This is an important concept. So we're right here. I'm going to make a form. And in that form, I'm going to put an input box. And I'm going to show you what I mean. Under that input element, I'm going to put another input element, type equals submit. Okay, so we just made a simple HTML form, and this is really, really important. I'll show you why it's important in just a sec. So here's our form with a little box. Okay, so if I visit this web page and I hit enter, I'm making an HTTP GET request, GET. If I click submit, I want you to watch this page is going to refresh. And watch up here, you'll see the little loading thing. It's not going to take long, but if I click submit, I am not making an HTTP GET request. I am making an HTTP POST request. And the difference is easy to remember, but you should always ask yourself when you're doing program, is this a GET or is this a POST? And the reason for that is when you're working with dynamic data, you need to know where it's coming from. And why I say that is there's only two places it's ever going to come from. It's either going to come from the address bar, and that's obviously not true. It could come from the database and the file system and all that kind of stuff. But generally, variables are either going to come from the address bar or they're going to come from the form. So we've all seen URLs that look like, whoops, that look like this, right? My value equals 1, 2, 3, 4, 5. Nothing's happening with that. But I, as a developer, am passing a variable in the address bar to this PHP page. And I could then use it. This is get up here. This is post. This is get. This is post. So if I wanted to get the value of this variable, actually let's call it something else, my variable. If I wanted to get the value of my variable, I would have to ask PHP for it. And I would generally do that at the top of the page, and then I could work with it. If, ignore the is set, we'll talk about it in just a sec. If that thing is available, then I'm going to make a new my value equals nothing. But if it's in the post, if it's in the URL, I'm going to say it equals get So that's the name or the key. We call them key value pairs. This is the name of the variable, my variable that I put in the address bar. This is its value. And I want that value because I can't do anything that I want to do without that value. Like I clicked a link on a map. I want to know what link did they click. Right? I clicked a screen on the control panel to change its order. I need to know what one they clicked so I can add that to the URL as a programmer, and then I can get it later, kind of top secret. So if we echo now my value, we're going to get 1, 2, 3, 4, 5, because that's the value right there. See there? And that's a get. If I submitted a form field with this same name, my variable, the name of the thing that I'm working with, watch right here. This won't print. So if I use a GET request, it will come out of the URL. If I use a POST request, it should not come out of the URL. Well, I'm a little, darn it, this is not what I expected, but this server's configured to take it from both places, and I didn't realize that that was the case, but generally what you have to do is get it out of the POST request. Generally what you have to do is get out, it's looking in both places for me kind of auto-magically right now, and I didn't want it to. Okay, there we go. Perfect. So I'm saying this variable here, I'm forcing it by looking at the POST variables, which come from the form, not from the URL. So my value is empty because there is nothing in this box. So if I typed in a value in this box and I submitted it, we get it. So the point is it a GET request or is it a POST request? It's very, very important because really the rule of thumb is if you're going to be changing data on your back end and allowing people to input information, you don't want to get it out of the URL. You want to get it out of the POST request. There's some security issues there, things like that. But that's the difference between GET and POST, is how we access these variables. Where was I going with this? Okay, so database stuff. We've gone an hour, Sue. Why don't we pause again? I'm afraid that talking about databases is going to take us another significant amount of time, and I'm willing to spend another half an hour or whatever, but why don't we end the recording now? Sure. And just kind of decide, or in a moment here, but just kind of decide that we did review the LAMP stack already. Mm-hmm. And I'm going to summarize this by saying it's not that complicated. Mm-hmm. It's an operating system, a web server, a database, and a middleware working together to help you get creative. You're the person, the developer, me, you, all of us. We're the people who need to take advantage of what this stuff will do for us by passing around these variables. So don't be intimidated by long address bars that have, tons and tons and tons of stuff in them. Right? I mean, it's crazy how many things you'll see sometimes, these big, long address bars on, like, Amazon. Mm-hmm. All that is it's just the developer's way to tell them what you're clicking. Right? It just helps them on the back end understand. If I go to Amazon.com, so far I haven't clicked anything, right? But when I click this 119, they need to know what in the heck I clicked. So they pass that information in the URL. And then they use it on the back end to answer my question. What web page should I make this guy? What prices should I show this guy? Right? This web page was not made in advance. It was made after I clicked the item, so it's dynamic. And Miguel might click the same link and see a completely different language. Jake might click the same link and see a completely different price. Because the programmers have decided that they can deliver to Apache, the web server, anything they want based on variables in the URL. So I think that that's a pretty basic description of what LAMP does. We bled off a little bit into some PHP logic, which I could do PHP all day long and show all kinds of crazy things, but I do think we'll tend to bleed over into the time. Happy to do that. I think that's what most people are interested in. But why don't you kind of wrap this up for us, Sue, and stop the recording, and then we'll chat a little bit with who's still here.
Yeah, sure. I'll just turn off the recording. Thank you all for coming, and turn off the recording.